Hey boys and girls, this is lesson 3.4, all about an equivalent fraction rule. Get your curiosity piqued? I hope so. Go ahead and write this in your notebook when you're done. Come on back. Okay, so if you look in your math journal at this page, let's talk it through. It says, color the circles and write the missing numerators. So the denominators are there for you. You can see that. The denominator's there, but the numerators are missing. So we're coloring it and writing the missing numerators. Let's go ahead and look at that first one together. So you notice for the first one, we've got 1/2. One of the two pieces is colored. So for the second one, I'm still looking to do that same thing. So I'm going to color in, I want them to be equivalent. So I'm coloring in, how many of the pieces there did I color in? I colored in 1, 2, 3 of them. So 3 out of the 6 were colored. And then I'm looking to continue to still do the same thing here. So if I'm going to color it in, I'm going to color in 1, 2, 3, 4, 5, 6 of them. Okay, so that's what I'm looking to do on this one, because I'm making equivalent fractions. So will you go ahead and do the same thing on this second and third row? So this time it's telling you to color 1/3 of each of the circles, so make sure that's what you're up to. And then 2/3 of each of the circles. So give that a try. When you have it done, come on back and we'll talk through the answers. Okay, so here are the answers. Let's start looking at these first. These we did together. For this one, 1/3. You could have colored any of the 1/3 parts. I hope you know that to be true. But let's go ahead and go with this example. So this is 1 out of the 3 that's colored. If I want to stick with this same thing to make it equivalent, now I need to do 2 out of the 6 to keep it equivalent. And then for this one, for those 12ths, I had to color 4 out of the 12 in order to keep that to be equivalent. And then when you look at this bottom one here, you can see that we're talking about 2/3. So going along with this pattern, although you could have picked any of the 2 of the 3, coloring 2 of the 3, which then means 4 of the 6, and 8 of the 12. I hope you noticed these are just fun ways to do it, but you certainly wouldn't need to, right? It could look like this. So if I think about things that I'm observing when I look overall at these patterns here, let's talk through some observations that hopefully you could make as well. So I hope you notice that for each problem, as you move from the left to the right, the number of parts increased. Here we've got 2 parts, here we have 6 parts, here we have 12 parts. So as those numbers increased, I hope you also noticed that the size of the parts decreased. When you look at this one little 12th here in comparison to a 6th and in comparison to a half, I hope you would see that, yes, the part decreased. So we got more parts, but the sizes are smaller. But even with that being done, the fraction region represented is the same. So really think this one through. The whole, I hope you could also have noticed that the whole remained the full circle no matter which of these we were talking about. We didn't change that. And I was talking down here really quickly that it doesn't really matter which pieces got colored as long as whatever amount you colored, as long as you had the same amounts colored as what this is showing. So any 4 would have worked. I probably would have done it more along this same shape myself and colored in all of these rather than what they did, because I like it to look the same as the one beside it. So for me, these 2 would more match this way, so that's probably what I would do. But you don't have to. So hopefully you figured that out. You wouldn't have to. And this one is showing that as well, that it doesn't matter as long as you get 8 parts shaded, that still would be the same amount, the same region represented. Okay? And then the last thing here is talking about, so whenever the total number of equal parts is increased by a factor, the number of colored parts increases by that same factor. And the fractional region then doesn't change. So let's talk that through. So for this one, for 1/2, it's saying if I increase the number of parts, so I've got 2 parts here, and here I have 6. If I increase that by a factor, so if I'm looking to go from 2 to 6, I'm going to multiply 2 times 3, right? 2 times 3 equals 6. So whatever that factor is, so that's increasing by a factor, the number of colored parts has to increase by that same factor. So let's see if that's true. So then I'm saying, well, I had 1. If I multiply it by that same factor, so times 3, then I would end up with the same amount. So look at that. So I increased the parts by a factor of times 3. Therefore, if I did the same on the number of parts, the number of colored parts, times 3, I would end up with a fraction that's equivalent. This colored region would be the same. And that may be kind of puzzling to you. Why is that true? Well, if you notice, in essence, I'm multiplying this 1/2 by 1, because 3 over 3 is 1, right? You know that the special fractions, 3 over 3, this is the identity property, or I could say 5 over 5, 100 over 100. You know that's the same as 1 whole. So this should make a little more sense now if you think that through. So if I'm multiplying this fraction by 1, I'm not changing its value, right? But I am, because I'm multiplying it by one of these special ones. I am changing the number of pieces. So this is a very big thing to make sure that you understand. If you need to repeat this and listen to it again, do so. But pay attention to how that goes, okay? Let's see if it would make sense if I did the same thing going from here to here. So if that's the case, and I say, so I started off with the half, and now I'm going to get to the bigger amount of fractions by what to get to 12? 2 times what? Well, 2 times 6 is 12. Whenever I'm going to do to the bottom, the total number of parts, I need to do to the shaded number of parts. So I'll do times 6, and that's going to get me 6/12. This will always work. We could think about this as an equivalence rule, which is what we're going to be discussing. So far with fractions, we've looked at figuring out equivalent fractions by using our fraction pieces. We've done it with using number lines, and now today we're going to push forward and come up with that equivalent fraction rule. Okay, so the equivalent fraction rule, so I've written it out for you here, and this is what it's saying. It's saying, so here's my fraction, a over b. So you know I'm using letters, variables, to represent any number, right? This is some algebra. We've had this conversation before, what variables are. So I'm saying this is any fraction, right? Could be represented a over b. So the equivalent fraction is saying, so this, any fraction, would be equal to any fraction multiplied by the same number on top and bottom. So for an example of that one, let's just look at one of the ones we just talked about. So we said 1/2 could be the same as if I multiplied it 3 times that 1 over 3 times that 2. Because the letter N represents it's on the top and the bottom, so it would have to be the same number top and bottom, right? So this hopefully makes sense to you now. This is the equivalent fraction rule. I can plug in any numbers I want here, as long as this number is going to be the same one top and bottom, right? So let's put this into practice. Look at this problem down here. So 6/10. In essence, I'm saying to myself, okay, so 6/10 is equal to what? If I'm saying I want this one to be 100, what am I doing to get from 10 to 100? So I'm looking to try and figure out what my n over n will be, right? So in this particular problem, what would my n be? Well, I know that 10 times 10 equals 100, right? 10 times 10 equals 100. So this would be my n. So if that's true on the bottom, it also has to be true on the top. So 6 times 10, 10 over 10 are my n's, right? So 6 times 10 then is going to be 60. That is a representation of this rule in practice, right? And then let's take a look at this one. So I could do it if I'm missing the denominator as well. So 7/10, A over B, 7/10 is equal to 70 over what? How do I figure that out? Well, let's take a look. Here we're saying, okay, so from 7 to 70, what am I doing? Times what? Well, I know that's times 10. So if I can do it on the top, I have to do it on the bottom, because whatever you do to the top, you have to do the bottom. Whatever you do to the bottom, you have to do the top, because we need this n over n to always be the same number. So now we're saying 10 times 10 then is equal to 100. See how that works? Awesome. Write this in your notebook. And then let's make sure that we understand I could go the other way too. So I could say that 30 over 100 is 3/10. So what did I do from 100 to get to 10? I divided by 10. That works as well. And 30 divided by 10 is equal to 3. So that works. 180 divided by 10 and 100 divided by 10 would give me this fraction. So I'm just using really easy examples with the tens, but they certainly don't have to be tens. And any number could be n over n, right? I could have those be 3s, 6s, 2s. It would not matter as long as it's not 0, because 0 we know doesn't work the same way. But any other number would work as long as it's the same. Okay, so you're going to do a little practice of that on this page right here. So let's take a look at what that's saying. So you can see that it's saying for this, everything underneath is going to be equivalent to 1/2. Okay? Everything's going to be equivalent to 1/2. So I could write this off here to the side for myself. So now I'm at 1/2, and the next one I'm going to make, it shows has a 4 on the bottom, right? I'm missing the numerator. So if I see this, what am I needing to do there? I'm trying to find an equivalent fraction. Now I could use my fraction circles, sure. I could use a number line, sure. But I can also use that new rule that we know, right? So if I apply that rule, what am I going to do to get from 2 to 4? Well, I'm going to multiply it by 2. Whatever I do to the bottom, I have to do to the top. 1 times 2 is 2. So I can fill this in as a 2. The next one is, I'm back to doing my 1/2, because that's the number I'm trying to be equivalent to. That's what's filled in the blue up here. So 1/2, and what I know on this one is that over here I'm going to have a 5. So now I'm saying, so how did I get from 1 to 5? Whatever I do to the top, got to do to the bottom. Here's my n over n. 2 times 5, 10. Right? Okay, you see if you can finish up this one for 1/2. So you've got 2 more that you need to do for 1/2, and then try it for the 4th and the 2/3. Be careful here, right? 2/3 now. Make sure you're following that same rule, and then you can make up a couple if you'd like for yourself down there as well, and then come back and check these when you have them. All right, hopefully you could see that I could do the 3/6 and the 4/8 the same way here. For the 1/4, I could do 2/8 and 3/12 and 25/100. And then for this one, I'm just going to quick write this one down for you. So it said for this 2/3 is equal to how many sixths? To go from 3 to 6, I would do times 2. So I'm going to do times 2. That's how I got my 4/6. And then the 8/12. And then if you made up some more of your own there, your answers will obviously vary based on what you came up with as well as in those practice problems. All right. Here's what your home link looks like. It goes back and gives you the equivalent fractions rule again so you don't forget it. And then it has a bunch of problems for you to try out. So give that a go. And make sure you do this practice down here because it's refreshing for you factors